Hey guys, welcome to Direction Sense. So, so let's look at the different directions and how they try to make questions out of directions. My name is Saravana, guys, and so you're watching this video from Sixth Place. So, some of the things that you'll be learning in Direction Sense. Uh, look at what the different directions are. Make sure that you have a thorough idea of which direction is positioned where, and the next thing will be movement and angles. You will have to know how to move, and your movement and angles depends upon the direction in which you are facing. Okay, so to put it simply, your movement and angles depends on the direction which you are facing. So I cannot tell you what clockwise is, what anti-clockwise is, if you do not know which direction you are facing. So all this comes under movement and angles, so we'll take a look at all those in detail. And we look at sun and shadows, depending upon where the sun is. If it is morning, the sun will be in a specific direction, right? During evening times, the sun will be in a specific direction. So suns and shadows, we look at where the shadows will be for a particular position during sunrise and sunset. And we look at this famous theorem, Pythagoras theorem. Without this Pythagoras theorem, guys, you cannot do any problem. I wouldn't say any, but most of the problems you cannot do it in direction sense. So we'll first make sure that we understand Pythagoras theorem, and then we'll move on to Pythagoras theorem applied in direction problem. So we'll have a look at the examples, and then we'll go through all the problems that we are going to solve in this section, guys. So first look at directions. So as you know, on the map, you'll always find this direction to be north, and this direction you'll always find it to be east, and this direction you'll always find it to be south, and this direction you'll always find it to be west. On a map, these four directions doesn't change. Okay, people often get confused, but I want to make sure that you guys don't get confused here. Okay, so whenever they talk about the north direction, okay, whenever they talk about the north direction, they are talking about this direction. Okay, there is no two ways about it. Okay, they're only the person, whoever like is writing the question, whenever he says north, okay, what he has in his mind is he's talking about this direction. Okay, this is north. Now whenever the person says east, he's talking about this direction. This doesn't change. Okay, east is always this direction. Okay, now whenever a person says south, he's talking about this direction. Again, this doesn't change. Okay, this is south, this is south. Okay, nobody can change this. This is fixed. Okay, now whenever people talk about west, they are talking about this direction. Okay, there is no change in it. Okay, uh, and I'll also like to take this further, guys, and then I'm going to give you four more directions. The direction that is between north and east. Okay, so look at this. This is where you find north, right? This is where you find east. The direction between north and east is what we call as northeast. Okay, so this one is called as northeast, and the direction between south and east, that we call as southeast. Similarly, the direction between south and west is what we call as southwest, and the direction between north and west is what we call as northwest. Okay, so I've given you four more directions. So I make sure you understand this. Okay, so the direction that is between north and east is called as northeast. The direction between south and east is called as southeast, and the direction between south and west is called as southwest, and the direction between north and west is called as northwest, guys. So I'd say on a map, you have not just four directions, you have eight directions. So these are those eight directions. So make a note of these directions. Whenever people talk about this directions, it is always this direction. Okay, so why do I say that it is always this direction? Why do I keep stressing the point that whenever people talk about this direction, it is always this direction, and it doesn't refer to any other direction? Why do I say that? Let me give you an example, guys. Look at this. Let us say somebody is going this way. Okay, now which is his left hand side? I'd say this is his left hand side, right? So this is his left. Okay. Which is his right hand side? This is his right hand side. Am I right? Now, let us take, let's suppose that he is going this way. He is going south. Okay. Now tell me which is his left hand side, guys? Is it this side? Will you write left here? No, right? It is not left. When he is going south, this will be his right hand side, correct? Which will be his left hand side. This will be his left hand side. Okay. So now this is not only for north and south. Let's treat this east. Okay. Let us try east. When somebody is going this way, which is left hand side, which is right hand side, and when somebody is going this way, which is left hand right. Okay. We'll see that when somebody is going in the east direction, left hand side will be this is left. Okay, right hand side will be this is the right hand side. Okay, but that is not the case when somebody is going in the west direction. Okay, this is west direction, right? When somebody is going in the west direction, left hand side is this one. This is where the left is, guys, and the right hand side is this one. Okay, so this is where the right is. Now see, left and right, you cannot say that a particular direction is left and particular direction is right. Okay, so you cannot have a specific direction for it, but for the rest of the 8 directions, but whenever they say north, it is always this direction, correct? Whenever they say south, it is always this direction. Whenever they say west, it is always this direction. Whenever they say east, it is always this direction. Okay, whenever they say southeast, it is always this direction. Okay, so there can never be a change in it. But left and right, it depends upon what? There is no specific direction which is left and which is right. Okay, your left and right depends on your the direction you are facing. Okay, so that is what I've been like telling you. If you're going on the east direction, your left hand side is this, but when you're going in the west direction, your left hand side is here. Okay, so similarly, when you are going in the north direction, your left hand side is here. When you are going in the south direction, your left hand side is here. So you can also see the right hand side also interchanged. Okay. So this is very important. This is one of the most important things that you can learn in direction sense, that don't mess up left and right. Okay. Your left and right directly depends upon the direction in which you are facing. Okay, so without knowing the direction in which you are facing, you cannot say which is left and which is right. But just by knowing north, you always know this is north. Okay, there you can know two ways about it. Okay, this is north, this is always north, this is always south. Okay, whenever they say north, they are always talking about this direction. It is fixed here. Okay, whenever they say south, they are always talking about this direction, right? Let's try to understand the angles here, guys. Most of you would already be familiar with this, but still I want to make sure that you know what the angle here is. Now the angle here will be this angle, guys. So let's take it, yeah, right? This angle here, guys, is, you all know, it is 45. Okay, this is 45, and this is 90, right? How much is this? This is 90. Okay, so from north to east it is 90, from north to northeast it is 45. Okay, similarly you also know that this is also 45, right? So this is also 45 degrees, so we can make this out to be 45. Okay, so similarly, guys, from here to here it is 90. What about let's say from here to here, how much is it? It is 90 plus 45, which is 135, right? So from here to here it will be 135. So let me clear this out and give you a clear uh, view of it. So if I ask you what is the angle between these two arcs, okay, sorry, these two lines, okay, you'd say this is 135, correct? It is because 90 plus 45, so you'd say this is 135. Now if I ask you what is the angle between these north and south line, what is the angle between the north and the south line? You know it is 180 degrees, right? It is a straight line, so the angle between on a straight line is 180 degrees. Okay, so that will be 180 degrees. So I'd like to give you one more. You know this is 180 degrees. Okay, I'll just give you one more. Okay, so you know that this is 180 degrees, or I should say this whole thing is, how much is this, guys? This whole angle is 360 degrees. Okay, this whole circle is 360 degrees. Okay, now half of this is 180 degrees. Okay, this whole circle is 360 degrees. So if you start from here to here, it is 360 degrees. Okay, from here to here, this whole circle is 360 degrees. You know that the angle in a circle is 360 degrees. What is the angle in a semicircle? Let us say that I do like this. Okay, something like this. Okay, yes. Now what is the angle here? Here you could say the angle is 180 degrees, so you'll say 180, and here also you'll say the angle is 180. Okay, so this semicircle, okay, so you see a semicircle here. Yes, this semicircle has an angle of 180 degrees, and this semicircle has an angle of 180 degrees. So suppose if I ask you what is the angle, let us suppose this is, so my question is A here, guys, and it is, yeah. So we'll have C here. Okay. Now what is the angle between A and C? If I ask you what is the angle between A and C, what will you say? A and C. Okay. A is this line, north line. C is this west line. What is the angle between A and C? If I ask you such a question, what will be your response? So you can see from here to here it is 180, right? From here to here it is 180, then from here to here it is again 90. So what is 180 plus 90? It is 270. So the angle between north and the west lines are 270 degrees, or I would say the angle between A and C are 270 degrees. I just want to give you a final look at all the directions, guys. Make sure that you have a final look here. So this is north, this is east, this is south, this is west. The direction between north and east is northeast and southeast and southwest and northwest. Okay, so here the most important thing is, where does the sun rise and where does it set? The sun rise, it doesn't rise in Japan. Okay, as first I'll tell you that. Okay, most of the students say that. Okay, they say that it rises in Japan. It rises on the east. Okay, the sun rises on the east and sets in the west. Okay, so this is where the sun rises. It goes like this and then sets over the west. So let's take a look at the movement and angles, guys. Okay, for example, let us suppose somebody is going uh, in the north direction. Okay, so while moving north, so this is north, right? So I've told you, whenever people talk about north, they're talking about north. Okay, so there is no confusion there. Okay, left and right, there might be a confusion, but north, this is north. Okay, it is always a north in the map. Now, if he turns to this direction, you could say this guy has turned 45 degrees clockwise. Okay, or you can say he is made a northeast turn. Okay, now how do I say that, guys? Now you know very well that the angle here, okay, that the angle from here to here is 45 degrees, correct? Yes, guys, so the angle from here to here is 45 degrees. So he has done a 45-degree turn. Okay, if he is going straight without doing a turn, he'll go this way, right? Okay, so you can also like mark it here. If he's going straight, guys, he'll go like this. Okay, there you can see my line very crooked. Okay, yeah. So if he's going straight, he'll go like this, but he's not going straight. he's made a 45-degree turn. So that is why it is 45-degree turn. Now why is it clockwise? Because this direction, if you do this, it is called clockwise direction. Why is this a clockwise direction, guys? This is a clockwise direction because this is how the clock moves, right? The hands of the clock move this way. Okay, what is anti-clockwise direction? It is this direction. If you go this way, just imagine the clock going in the reverse direction. If it goes in the reverse direction, it is anti-clockwise. This is clockwise. So because this is how the clock moves. Okay, so that is where the name comes, clockwise and anti-clockwise. It is because of this reason. Okay, so it moves 45 degrees clockwise. So we can call this turn a 45-degree clockwise turn, or you could call this a northeast turn because direction wise is moved northeast, right? So this you can call it a northeast. Okay. Now, if he does this, okay, now we have three names for this, not just two names. We have three names for it. Let's see what it is. Okay. First one is he's done a 90 degrees clockwise turn. Yes, I hope by now you understand the angles and the clockwise thing. Okay. Now he's made a 90 degrees clockwise turn. He is, or you could say direction wise, he has done an east turn, right? This is the east. Okay, or I should say this is east. Okay, there is no other east. There is only one east, that is this east. Okay, so this is the east turn. Okay, and you could also say here that he is made a right turn. Okay, he is made a right turn. Okay, so you have to be careful, guys. While moving north, east is right, but while moving south, will east be right? No, no, we'll see that in the subsequent slides. But right now, you understand that this is also a right turn. Now, now pause the video. I want to pause the video at this point and tell me the first name that we give this. Okay, some degree, usually clockwise or anti-clockwise. Okay, right? So I want you to give me that name. Okay, pause the video, come up with the name, and then double check your answers after that. So if you pause the video and come up with answers, you should get this, guys. 135 degrees clockwise turn. Okay, so again, why is it 135? So up until here we have 90 degrees. Okay, from here to here again it is 45 degrees, right? So you add the 90 and 45, you will get 135 degrees. Again, it is a clockwise turn. Okay, so this you could also call it a southeast turn. Okay, this is southeast direction, so you could also call this a southeast turn. Okay, now look at what he is doing. Now again he is doing 45 degrees, but this time he is going against the clock's direction or anti-clockwise direction. Okay, so we call this a 45 degrees anti-clockwise turn. Okay, so again I hope you understand how 45 degrees came about. 45 degrees came about because the angle between this line and this turn, okay, this line, had it been straight, it would have been like this, right? So now the turn here is 45 degrees, and this is in the anti-clockwise direction. Okay, against the clockwise direction, so we call this a 45 degrees anti-clockwise turn, or you could also call this northwest turn. Now this is 90 degrees anti-clockwise turn. You could also call this the left turn, and you could also call this the west turn. Okay, so you have three names. Why do you call this the left turn, guys? While going north, this is left. While going north, this is right. Okay, so you can call this 90 degrees anti-clockwise turn. You could call this left turn. You could also call this west turn. And finally, again, I want to come up with, pause the video, come up with a name for this. I hope everyone gets this right this time. Okay, guys, so I hope you got the name for this. So this is 135 degrees anti-clockwise turn, guys. So up to here, it is 90 degrees, and you have an extra 45 degrees here. So you will have 135 degrees. Okay, so this is 45, the extra 45. So 45 plus 90 will give you 135. So this is 135 degrees anti-clockwise turn. Okay, or you could call this the southwest turn. right? So this is not the this is somebody moving south, guys. So while moving south, so what happens is, see, now what would you call this direction? This is actually southwest direction. Okay, so will you call this southwest turn? Will you call this southwest turn or northeast turn? Which will you call this? You should call this southwest turn. Okay, I told you in a map, okay, in a given specific map, this is always south, this is always north, this is always east, and this is always west. You cannot change that. Okay, so this is because this is also, I'll also name it for you, okay, just for the sake of convenience, guys. This is always west, guys, this is always east, okay, this is always north, and this is always south. Okay, now this, while somebody is going south now, okay, now that doesn't mean, now people will try to make this to be a northeast turn, because if you look at it from the perspective of somebody who is going south, it might be northeast. But I told you north, south, all those things you have to look at the map and then decide. Okay, in your map, this is always the southwest direction, this is always the southeast direction, this is always the northeast direction, this is always the northwest direction. There is no changing it. Okay, so don't make that mistake. But one thing that doesn't change is, okay, you can clearly see when he is going this way, this is his clockwise direction. Okay, this direction is his clockwise direction, this direction is his anti-clockwise direction. So that way he does a 45-degree clockwise turn. So you know it is a 90-degree clockwise turn. It is a west turn, guys. I hope you understand why it is a west turn, and it is also a right turn. Okay. In the previous example, while somebody was moving north, it was the left turn. West turn was the left turn, right? But here it is right turn. I hope you understand why it is. Okay. So it is west here because this direction is west. Okay. So you cannot change it. So it is a west turn, but it is a right turn because while going south, this side is the right side. Okay, this side is the left side. And by this time you should know this is 135 degrees clockwise turn, and you also call this a northwest turn. Okay, now this side you could call this 45 degrees anti-clockwise turn, or you could call this southeast turn. You could have three names for this 90 degrees anti-clockwise turn: left turn or east turn, and the last one is 135 degrees anti-clockwise turn, or you could call this northeast turn. Okay, just make sure that you understand, guys, that the most important difference here is that left turn, and here it is right turn. Okay, this left and right will vary. Okay, that is what I do. You cannot have a specific left and right. You cannot say this is left, this is right. It depends upon the direction in which somebody is facing, okay, or somebody is traveling. So let's see the next direction. The next one is, if somebody is going east. Okay, when somebody is going east, so this is 45 degrees clockwise turn and also southeast turn. Correct, this is between south and east, right? So this is a southeast part of the map, guys. So this you can call it as 45 degrees clockwise turn or southeast turn, and this you can call it as 90 degrees clockwise turn or south turn or the right turn. Okay, so this is right. Okay, right now south is the right. Okay, so again you can see this east determined that, okay, the east direction said that if you turn right you will go south. Okay, you turn left you will go north. Okay, now how do you say that? It is because of east direction, because in west direction it is the opposite of that. Okay, so we'll see, have a look at that also. But here understand that the right turn is associated with south. Okay, and this is also 90 degrees clockwise turn, guys. So the next one is 135 degrees clockwise turn, and you can also call this a southwest turn because this direction is between south and west, right? So you will have south here, you will have west here. Okay, so okay, so you'll have south here and you'll have west here. Okay, so this is between south and west, so we call it southwest turn. So the next one will be anti-clockwise, and it will be 45 degrees anti-clockwise turn, and we also call this the northeast turn, and we have three names for this: 90 degrees anti-clockwise, north turn, or the left turn. Okay, so here we have the left turn associated with the north direction. Okay, and finally we have 135 degrees anti-clockwise direction or northwest turn. And we'll be finishing this off with the west direction, guys. In west direction, what happens while somebody is moving west, this we'll call it as anti-clockwise direction, right? So is this clockwise or anti-clockwise? Okay, when somebody is moving in the west direction, what would you call this as? This is anti-clockwise direction, this is clockwise direction. Okay, so you have to be careful about it. So this is actually 45 degrees anti-clockwise direction or southwest turn. Okay, this is actually 90 degrees anti-clockwise, or you could call this, is this the right turn? I've mentioned here as right turn. Is it right? Is right turn right? This is wrong. Okay, this is not right turn. Okay, so you associate left turn here. Okay, this is actually wrong. Okay, but I wanted to see if you guys spotted it. Okay, so what do you do? So you, instead of right, you should mark this as left. Okay, so this is actually left turn, and it is associated with south. Okay, and this is 135 degrees anti-clockwise turn, and you could also say the southeast turn. This is 45 degrees clockwise turn, and it is northwest turn because it is between north direction and the west direction. This is here you will have three names for it: 90 degrees clockwise turn, north turn, and a right turn. Okay, this is actually a right turn, guys. This is not a left turn. This is wrong. So we'll change it to be right turn. And finally, we have 135 degrees clockwise turn, or we could call this northeast turn because this direction is between north and east. Okay, so this is what mostly you need to know. I just covered everything that you need to know to solve any type of problem, guys. Okay, we have one more section. We'll come back to this section. Okay, so but mostly we have covered everything. Okay. Okay, now we are going to look at some objects and their shadows depending upon the position of the sun. Okay, so usually we have two positions that we consider, or I should say three positions, guys, when the sun is rising, when the sun is setting, and exactly at 12 noon. Okay, when the sun is rising, you'll have a shadow. When the sun is setting, you'll have a shadow. And in between you will have shadows, okay, which vary in length depending upon the time at which you are observing, okay, but at one point you won't have a shadow. So do you know what point it is? At one point of time there won't be any shadow. At what point is it? Don't say midnight. Okay. Yes, it is at 12 noon. Okay, so between morning and evening, before the sunset and this, between the sunset rise and the sunset, okay, you will find that at 12 noon there won't be any shadow. Okay, so if they refer that point in any question, you'll have to know how to answer it. Okay, 12 noon, no shadow. Okay, you cannot observe shadow wherever you are. Okay, now you guys, you know this, these are basics: north, south, east, west. Okay, I want you to make sure that you know these directions. Okay, so this is north, this is south, this is east and west. So where does the sun rise? Sun rises in the east. Where does it set? It sets in the west. Okay, so depending upon that, we'll see how the shadow of a person or an object, okay, which is positioned, uh, how does the shadow behave, okay, for different positions of sun. See, right now we have an object which is facing north, right? This object, this point shaped object, guys, which looks like a pyramid. Okay, so if you want, if you take this to be a pyramid, this is facing north. Okay, now when it is facing north, you see that the sun, look at where the sun is. The sun is at the rising position. It is rising now. Okay, so you could say there is sunrise here. Okay, so sun is rising here. When sun rises, okay, now where will the shadow be? Okay, on which side of the object will the shadow lie? Is it towards its left or towards its right? Okay, so you could pause the video, just think about it, and then come up with your answer, guys. Okay, so pause the video right now and then think of where the shadow will place itself. Will it be on the left side of the pyramid or object, okay, or will it be on the right side, okay, during sunrise? Okay, so you can see where the sun, during sunrise you can see the sun, so approximately that is where the sun will be. Okay, so this, I'll point it out for you. So this is where the sun is at this point. Okay, this is where the sun is. So you have to tell me where the shadow of this object, okay, will fall. So pause the video and then we'll continue after some time. So I hope you paused the video and got the answer, guys. Now at this point the shadow will be like this. Did you see the shadow? Yes, yes, it will be towards, the shadow will be towards the left side of the object. Okay, the shadow will be towards the left side of the object. So you should say it could be an object, it could be a person. So if it was a person which was mentioned in the question, you could say the shadow falls on the left side of the person. Okay, that is how your answer should be. Okay, now we'll see what happens. These are basic directions, guys. Now the object is facing south, right? Now the object is facing south. Now where is the sun? The sun is again rising, guys. So on the east direction it rises. Okay, so this is the east direction. So in this direction it will rise. Okay, so the sun rises. So in this direction, east direction, the sun will rise. Okay, so what happens? The sun is rising. So the sun rises here, but the object is facing southwards. Okay, when it is facing southwards, now tell me, will the shadow fall towards its left side or towards its right side? So that is my question. Where will the shadow fall? Okay, will the shadow fall towards its left side or towards its right side, guys? This is where it will fall. Is it left or right? So the shadow falls on its right side. Okay, so again here you can see left and right dependent of was dependent on what, guys? It was dependent upon which direction the object was facing. Okay, so in the previous example the object was facing north, so we call this left hand side. Here this object is facing south, so we call this right hand side. Okay, the side hasn't changed because the sun is here. In both the cases the side hasn't changed, but the direction in which the object or the person is facing has changed, guys. So this is one, again, this you already saw this in previous examples. Right and left dependent on was dependent on what? It was dependent on the direction in which something was facing. Okay, here also it is dependent on the direction in which the object is facing. Now we'll take the sunset. Okay, so where does the sun set? The sun sets on the west side, so pay close attention to the west side. So the object is facing which direction, guys? The object is facing the north direction. Okay, now here this is the sun setting. Okay, so you could say the sun is setting, and you can see where is the shadow? The shadow is towards the right hand side. Okay, the shadow is towards the right hand side, so you can clearly see the shadow is towards the right hand side. Now this is the case when the object is facing north. Okay, what happens when the object is facing south? Like in this case, guys, here the object is facing south. Where is the sun? The sun is setting. Okay, now where do you think will be the shadow for this object? Will it be on the right hand side or the left hand side? Because sun is setting, it will be towards the left hand side. Okay, so see, this is where the shadow comes up. So the shadow will be towards the left hand side. Okay, so I hope you understand how you do problems involving sun. Just make sure you understand that sun sets in the west and sun rises in the east, and at 12 noon you'll never have a shadow. Okay, so that thing you have to make sure that you understand. And the whether left or right where the shadow falls depends upon the person, or depends upon the direction in which the object or the person faces. Okay, now I'm just going to give you one question. Let's see if you're able to answer it. Okay, let us suppose, okay, so let us suppose that the object here, guys, um, let us say, okay, now the object is facing this way. Okay, the object is facing east. Okay, yes, object is facing east. Okay, so now where will the shadow lie? Okay, now when the object is facing east, the shadow will lie here. Okay, so the shadow will lie on, it is not right side, it is not left side, I'd say in front of the object. Okay, the shadow will lie in front of the object. Okay, so it is not left and right here. Here the shadow will lie in front of the object. Okay, so this is for this. Let us suppose that the object is like this. Yes, this is the object, it is facing west. Now the sun is setting, guys. Now sun is setting, where will the shadow lie? The shadow will lie towards somewhere here, right? Yes, because guys, you have to understand this is not flat, this is standing up. Okay, it is standing erect. Okay, this is a standing erect position, but it is facing west direction. This is also standing erect. Okay, pointing towards the sky. Okay, this point, both this and this points towards the sky. Okay, but it is facing the west and this is facing the east. Okay, that is why I say the shadow falls in the front. Here the shadow falls towards the back side. Okay, so this is where the shadow will be, so write it as back. Okay, so this also you'll have to understand. So here we've come to the most important part, guys. No, yes, some 10 to 15 percentage of your direction sense questions you can do it without knowing this, but you cannot solve the remaining 85 percentage of the questions if you don't know Pythagoras theorem. Pythagoras is a famous mathematician during the Renaissance era, um, and his theorem has to do with triangle. Okay, and specifically right hand angle triangle. When do you call a triangle a right angle triangle? So you can see, take a triangle which is A, B, C, and this side B is 90 degrees. Okay, the angle B is 90 degrees. Okay, when one of the angles of a triangle is 90 degrees, we call it a right angle triangle. Okay, when one of the angles in a triangle is 90 degrees, we call it a right angle triangle, guys. So this we call it a right angle triangle because one of the angles is 90 degrees, and you know that the sum of the angles in a triangle, okay, A plus B plus C will always be what, guys? Will always be 180 degrees. Okay, so because if one of the angles is 90 degrees, the rest of the angles A and C cannot be 90. Okay, because the rest, the sum of the A and C can be 90. That can be 90. What you can say is, if B is 90, okay, if B is 90, we say it is right angle triangle, right? So we'll make this B to be 90. When B is 90, A plus C, the sum of A plus C will be 90. Okay, so this we call it as uh, complementary angles. Okay, A and C are complementary angles because sum of them is 90 degrees. Okay, so you cannot have A to be 90, you cannot have C also to be 90. Okay, so there is only one angle in a triangle which can be 90 degrees. Okay, so and that angle here is angle B. Okay, now why do we worry about this right angle so much? Because only when you identify which angle is 90 degrees, we'll know which side is hypotenuse. Because according to Pythagoras, what he says is the angle opposite, or the side, not the angle, guys, the side opposite to 90 degrees. Which side is opposite to 90 degrees? I hope you understand that we have three sides here. Okay, the first side is AB, the second side is BC, the third side is AC. Okay, you have three sides here. So let me put it out here, three sides. Okay, AB, BC and AC. Now the side opposite to 90 degrees, which is the side opposite to 90 degrees, guys? It is this side, and this side is called the hypotenuse. Okay, this side is called the hypotenuse. Okay, in a triangle, and especially in a right angle triangle, you must know which side is hypotenuse, which side is opposite, and which side is adjacent. Okay, by knowing this, you'll be able to solve problems very easily. Okay, so let us take this all outside and let us understand that this is 90 degrees. And on one more important thing is, you have to take this other angle to be theta. Okay, this angle, this other angle to be theta. You either take this as theta or you could take this as theta. Okay, it doesn't matter. Okay, now the side opposite to this angle theta is called the opposite side. Okay, the side opposite to this angle, which is AB, is called the opposite side. Okay, and the side adjacent to it. Okay, now what are the sides which are adjacent to this theta, guys? The sides which are adjacent to this theta are this side and this side. Yes, both are adjacent to theta. Okay, adjacent means it is touching. Okay, which, but you can see this is not touching, this is opposite. Okay, so this side is called opposite. AB is opposite. We already have given AC a name, hypotenuse, right? Because the side opposite to 90 degrees, AC, we've already given it a name which is hypotenuse. Okay, so you cannot have that to be adjacent, but you can have BC to be adjacent. Okay, but both BC and AC are adjacent to theta. Okay, but because we've given it a special name, we don't consider AC to be adjacent, we consider AC to be hypotenuse, and we consider BC to be the adjacent side. So if you take all this into consideration, you will have in triangle ABC, angle B is 90 degrees, guys. So because angle B is 90 degrees, side opposite to angle B is AC, which is hypotenuse. Side opposite to theta, which is AB, is called the opposite side, and side adjacent to theta, which is BC, is called adjacent side. Okay, so as you can see, this is adjacent, this is hypotenuse, and this is opposite. Now, why did we name this? Why did we go take the trouble of like understanding all this, guys? It is to arrive at the final answer. Okay, according to Pythagoras, what he says is this hypotenuse square, right? This hypotenuse square will always be equal to opposite square plus adjacent square in a right angle triangle. Okay, so this is the most important finding that we credit we credit with Pythagoras with. Okay, so he is the father of this Pythagoras theorem. I mean he I don't think much of many of you know this. Pythagoras also, he also found a constant. Okay, it is called the Pythagorean constant. It is the first irrational number. So he is not just remembered for this, he is also remembered for that also, Pythagorean constant. But mostly whenever people say Pythagoras, it is this formula: hypotenuse square is equal to opposite square plus adjacent square. Okay, so we'll use this. We'll see how we use this in solving problems. Okay, how do we use this? Why do we need a Pythagoras theorem while solving a direction sense problem, guys? So what is the reason? Okay, so we'll also see what the reason is and solve the problem here. So Pythagoras theorem applied in direction problems. Okay, we'll see that now. Okay. Now a child was looking for his father. Okay, so this is a typical direction sense question. So make sure that you listen to this very carefully. A child was looking for his father. He went 90 meters in the east before turning to the right. He went 20 meters before turning to his right again to look for his father at his uncle's place 30 meters from this point. Now his father was not there. From here he went 100 meters to the north before meeting his father in a street. How far did the son meet his father from the starting point? Okay, so in essence what they're asking is, so the son would have started at some point, right? And he would have found his father at some point, right? Now, what is the distance between those 2 points? That is what they're asking. To put this whole question in simple terms, there will be a starting point, there will be an end point. You have to find the distance between the start point and the end point. Now, how do we go about doing it? Um, uh, that is the crux of that is the important part of Pythagoras theorem. Sorry, that is the important part of the direction problems. But we use Pythagoras theorem for it, guys. Okay. Now, one advice that I give is, sorry, two things that you must remember. First thing, okay, if you've attended the blood relations, I suppose that you understand how important it is to represent the given words in diagrams. Okay, so it will make problem solving easier. Similarly, you will have to represent whatever is given in words as in a diagrammatic format. Okay, and it is very easy compared to blood relations. Here you just have to put lines. You just have to know where to go. Okay, when they say left, you have to know where to turn. When they say east, you have to know where to turn. Okay, so that is the only part. So that is why I spend most of this video making sure that you understand what is east, what is right, what is clockwise, what is anti-clockwise, what is 90 degrees, what is 270 degrees, all those things. Okay, now so let's take it step by step. Okay, take it slow. So a child was looking for his father. He went 90 meters in east. Now I've told you east is always this direction. Okay, you people remember this. East is always this direction. Okay, it doesn't matter where he is facing. You don't need to worry about where he started, all those things. East is always this direction. Okay, west is always this direction. North is always this direction, south is always this direction. Do you remember this? This was the first thing I taught you in this lecture. Okay. So what happens is, so he's starting now, he goes 90 meters east. So he starts, and what is this distance? This is 90 meters, right? So he starts and moves 90 meters east before turning to his right. Now what is his right side now? Is it south or north? He's going eastward. Now his right side, is it south or north? Okay. Yes, I hope most of you given the correct answer. It is south. Okay. Now he goes south for 20 meters. Okay. So this is the distance here is 20 meters before turning to his right again. So again he is turning right. Now which direction he'll turn? Should he turn east or west? He should turn west. Yes, when he is going southward, his right side will be west direction. So he turns west and travels 30 meters. So this direction is, I mean, this length is 30 meters, guys. And he reaches his uncle's place. So this is his uncle's place. Okay, and from this point, his father was not there. Okay, so at this point, his father was not there. So what does he do? He from here he went 100 meters to the north. Okay, now what is north? I've told you here whenever they mention the direction, it is always the direction you know as you know in the map. Okay, this is the north direction. So from here he'll go north 100 meters. Okay, meaning from here he'll go like this 100 meters. Okay, now here he meets his father. Okay, so the length of this is 100 meters. Here in the street he meets his father and comes to his end point. Okay, now guys, just look at the start point and the end point. Okay, now you can if they ask you to find the distance, you could say, yes, you could say let's say, let's take this from here to here. What is the distance, guys? It is 60 meters, right? It is 60 meters. Okay, so you could say it is 60 meters plus from here to here it is 80 meters, right? So you could say it is 60 plus 80, 140. Yes, that is one possible conclusion. Similarly, you can also say this, right? You here it is 80. This way also he can reach the end 140. Okay, you can have 140 as the answer. Okay, but in all directions sense, but if you say 140 or if you come to the conclusion that 140 is the correct answer, then you're wrong. Okay, the reason is, listen to this very carefully. In all direction sense problems, okay, in all direction sense problems, whenever they ask you to find the distance between 2 points, here it is start point and end point, correct? Whenever they ask you to find the distance between 2 points, it is always the shortest distance. Now what is the shortest distance between 2 points, guys? What is the shortest distance between 2 points? So let us take, you have a point over here. So you have a point here and you have a point here. What is the shortest distance? See, you can go like this. You can go like this. Yes, like this and reach this point. Okay, or you can go like this and reach this point. But what is the shortest distance? The shortest distance between these 2 points is always a straight line. Okay, so by this what I mean is you have to find the straight line between these 2 points. So this is the straight line between these 2 points, the dotted lines. Yes, are you able to see the dotted lines? So you have to find this length. So this is where the Pythagoras theorem helps you. Okay, what is the reason? Because we have a 90-degree here, correct? This we have a 90-degree, not only a 90-degree, just name it as ABC, guys. ABC. Okay, so if you name it as ABC, okay, just a minute, give me a minute, guys. See, can you see A, B, and C? Yes. So if you name it as ABC, this is the 90 degrees. Okay, so I'd say this is 90 degrees, right? This is the 90 degrees. So which is the hypotenuse? This is the hypotenuse. Okay, so right now you just have to know this length and this length. Okay, and you can just use it in the formula. So if you use it, you will see that AC squared is equal to AB squared plus BC squared, where AC squared is your hypotenuse square, guys. Remember, hypotenuse square is equal to opposite square plus adjacent square. So which is the opposite side? The opposite side is BC square. Okay, because theta will be here, right? You can take theta here. Okay, so BC square, adjacent will be AC square. Okay, so you can take any which way. Okay, so if you take the angle theta to be here, this will be opposite. AB will be opposite, BC will be adjacent. Okay, but anyway, you'll get the same formula. AC squared is equal to AB squared plus BC squared. So AC squared is equal to 60 square plus 80 square. Okay, the length of AC is AB is 60 and BC is 80. Okay, so if you solve this, you'll get root of 60 square plus 80 square, which is 100 meters. And see, it is not 140 meters, it is 100 meters actually. Okay, so whenever they talk about the distance between 2 points, they are indirect, they won't say it is the shortest distance, but you will have to find the shortest distance. So that is why Pythagoras theorem helps you. Okay, guys.